All right. Okay, so we're back to this instead. Hold on, I need to send a tweet out concerning... Let's see, there seems to be an issue with my capture card. So I will postpone Atelier Meru until tomorrow. Hey Ken, welcome to the stream. And so sorry for the issues today. I'm not sure what's going on with my capture card, but I did everything I could with the software that I can think of. Restarting it usually helps. Restarting my computer usually helps. But today we're gonna be going back to this game. So I actually started this last night. Wild True Learn. So this is a game about machine learning, which is a bunch of AI stuff. If you're not familiar with that. But let me send this tweet out really quick to let others know that we're switching gears here. There seems to be an issue with capture cards. I will postpone them until tomorrow. Instead, we'll be picking up on machine learning again today. Machine learning again. Picking back up on machine learning. Back up machine learning. Starting now. Yeah, actually the cat is a whole lot smarter than our dude over here. Basically how the story started out is that our guy here was doing some code and he got stuck. He got stuck on some problem, so he took a little break, and when he came back he found his cat had fixed whatever problem with his code that he had. So it's like, wow, really, cat, you're that smart, but we can't talk to our cat, so we don't know what they did. So to understand our cat, we're trying to make an AI that can understand, on the computer. We're trying to make an AI that can understand what the cat is saying. All right, that tweet is sent, and now I gotta alert everyone. Let's see. So this is going to be issues with capture card. Doing this instead today. Picking back up. And yep, Kugel and cat overflow. It's great. It is great. So if you're a programmer to any degree, you will know that Kugel and cat overflow are very much a thing. Hey Doobie, welcome back. Sorry about the capture card issues earlier with Meru. We're gonna pick that up again tomorrow. I'm gonna try to figure out what's the issue later, but for now we are going back to this. We are going back to this, and actually, so hopefully I don't fry your brains too much today, but it's interesting. To me, it's interesting that we're actually learning some basic machine learning concepts through this game. So if you have any questions, I know some, I'll repeat again for anyone who's new to this part of the stream. My background in programming is that I have made some websites from scratch. I made some applications for actual work things, laboratory things. Yabuki. Okay, well, I'm gonna check that out later. Dubi Yakubi. Hey, American Bison, welcome back to the stream. I'm sorry for the issues earlier. Today we're going to be doing some machine learning instead. And so as far as this game is concerned, let's just go back to this. So as far as this game is concerned, it is basically a puzzle game essentially, but with real concepts in machine learning as shown down here on the lower right. I guess the mouse doesn't capture. Can you see my mouse? Yes, it is cat. This is all about cat. We're trying to make a machine learning AI to understand our cat. But yesterday I got stuck on this Metal Gear construction factory problem. Let's go back to the text really quick so that we know what we're dealing with. Where's the text to the problem? There we go. Boxing license so you can try and do a legit debut. Nice. Very nice. Okay, so we tried to do this Metal Gear construction factory problem last night. We had to get through this to do another quest. So basically the side quests in this game just earn you a little bit extra cash to buy parts and things. And this was one of them. I'm not doing all the side quests, just the ones that looked interesting to me. And this one, we're supposed to make an AI that sorts out raw materials, because it's too raw materials for like steel and stuff, because it's a little bit too slow to do it by hand. Yeah. And actually, I was playing around last night. With this one to try to figure out if I can get close enough to an answer before I tried to solve it on stream, and I accidentally solved it with a gold medal yesterday off stream. So I'm just gonna go through the solution really quick. So originally this is what I had. So these are our tools that we're given. We don't have more tools than this. We have a decision tree that sorts by color, and a sorter over here that sorts by shape. This is the machine AI learning with some 20% error rate. I think that's pretty terrible, but it is what it is. So first things first, I sort everything by color over here, because the only colors we want are, well, we want all colors, but it seems like the only ones that are red are the circles and squares. So we sort out red up here, and any red circles and red squares will be sorted down here and delivered. If we get any triangles at all, because what happens to green here? Green gets randomly sorted top and bottom. So if we get any triangles and it's sorted up here, that's going to go into the trash can. We hope it goes in the trash can, but there's a 20% error rate. So we do have a 60% accuracy for this test that we got to clear, which is pretty terrible. It is pretty darn terrible. But I guess that's good enough for the most part. And down here we sort blues because there's a lot of blue parts, and if we're going to clear a 60% error rate, we want to make sure that at least the blue parts are somewhat accurate. So when I tested this yesterday, we get way above 60% error rate. However, the timer up top says that we're a little bit too slow. We have 28 seconds to clear it with a gold medal. I got 29.8. That's not quite good enough. So I was messing around and got to this. Basically, what I did was remove one of the shape sorters out and thought to myself, okay, what if we just tossed in all the red parts into this output over here? We might get some greens mixed in, but we have a 60% error rate, so I think that will be acceptable. At least the blue ones will be sorted down here. If we get any blue squares or blue circles, we'll just toss them out, hopefully. And blue triangles, if they do make it through, we'll go up here. Greens will be sorted randomly top and bottom. Hopefully there's some green triangles that'll make it over here, and most of the green circles and squares will be discarded. Hopefully, that's the hope. So when I tested this yesterday, rearranging bacteria and such made by scientists show what looked like a function. Oh, that is interesting. It's not spore, is it? It's not spore, is it? Because spore's a little bit different. But if I would like to look into that one, and just because it's I do like trying sciencey stuff once in a while, like this one. Science, yes. I am a scientist. I do have a degree. Not a PhD, but I do have a master's degree in a medical, no, not medical, molecular pathology. So I am a biology background, but I do like the computer science stuff and physics, all the sciences really. But anyway, I tossed this hopshot solution in there, and somehow we got a 62% accuracy. So we cleared 60%, and it clears in 21.6 seconds. Like, what the heck? All I had to do was take out one of the sorters over here and send red directly into this. I was just messing around and trying to, and somehow this worked. So as you can see, most of the red makes it through. Some of the green make it through. Hey, computer science is still science. But anyway, we helped the Metal Gear company get their stuff sorted. This toy manufacturing thing was something that I wanted to check into because of the neural networks. So let's just check this really quick, and then we'll keep going up this chain. Yeah. Sorry, I'm being a nerd today, but you know, I have to at least live up to the persona once in a while, the nerdy persona once in a while. Okay, nuke your toy. What? Nuke your toy. New technologies in toy manufacturing. Howdy, I'm contacting you on behalf of Nuka Toy. Oh my gosh. Nuka Toy. So is this like a Fallout reference now? We design and manufacture toys for children using 3D printing technology. There are 3 types of raw materials we use for printing, and we need an algorithm that would distribute them correctly. Not in this game. Nope, I don't sell refined. Sell refined weapons in this game. We might be able to do something with AI, but we don't do that. No. Maybe in that Atelier games that will sell bombs and such. Scientists uploaded a model of a virus and trying to make a breakthrough on it, and gamers surprisingly made a breakthrough for them. And scientists make progress at it. That is nice, yes. That is great. It's funny because sometimes you get scientists thinking one-track mind, and I mean, there's a lot of scientists that are gamers also. But once you start getting into like PhD, once you get into like PhD programs, your mind tends to not think that way for the most part. or any graduate school thing. You tend to be solely focused on how the thing is supposed to be done. Anyway, 3 types of raw materials produced for printing and need an algorithm that would distribute them correctly, passing a certain error threshold. Okay. Well, so far nothing too complicated. But it seems like we need at least 2 sorters here. We have 2 input streams somehow. We can only use 4 nodes. Well, as far as I can tell, we're gonna need 3 of these and maybe like a trash can every so often. So let's go and connect one of the input streams to our shape sorters over here. So circles need to go up here unconditionally from this one, but we need 30 circles up here. Let's toss that out first. So we need to send some circles up there. So squares and triangles. Somehow. So there we have, so 30, 45. Oh my gosh, we need 100% 100% accuracy on this bottom one is not difficult. The 30 that we got to send in the middle though is going to be a little bit more difficult. Actually, maybe we don't need to send circles up there. Maybe some circles can randomly get up here from this side. That might work out. So in that case, let's send some squares here and send some squares down here. Still got a decent amount. Maybe send some triangles down here, send some other triangles down here, and circles. I guess we'll still try to send circles up there. Well, let's see what happens. Let's go. Let's train our AI. Right now it's a 75% error rate. We need to take that down to 20%. That way we can train it. So whenever you first create a machine learning algorithm in general, and I've messed with this a little bit before, you have to go through so many repetitions on the algorithm to get the error rate down. That's called teaching, and I'm still not clear on how it actually learns, because you have to give it a right answer and wrong answer, and it has to somehow sort between correct answer and incorrect answer. RIFB protection. I don't know anything about RIFB. What is RIFB? I don't know what RIFB is. I'm assuming it's not Rhode Island Farm Bureau. I'm assuming it's not that. RIFB protection. Or you mean RFID? Are you talking about RFID? Because if it's RFID, that's a different thing, and that is from what I understand, it's just like a plating to block out some kind of signals. What radio frequency identified? Okay, so it's some kind of plating that blocks radio frequencies from scanning your stuff. So I don't know specifically because I'm not an expert about this, but from what I understand, some sort of plating that blocks waves. That's about it. Okay, so training's done. Let's sort this out and see if we can even clear it in time. I'm assuming this is how you're supposed to do it. It doesn't make sense to make a third sorter in here. Otherwise, it just increases our sort time. Okay, it kind of sort of works. It kind of sort of works. I think what's happening here is we're not sending enough materials. Basically, today's credit cards have an approximation feature where you don't have to pass your card, just move it close. But some people can rob you just by reaching a paying device and park it. Yeah, it's a convenience thing, right? I've never used it myself before because like I could never get it to. I could never get it to work with my card, even though technically my card has a tap feature also. And it's not just cards too. Apparently passports also are a thing. Though I don't know how useful that would be for passports unless it's to get your passport numbers which can be traced or something like that. I don't know. But yeah, for cards, especially if you don't have a verification, because a lot of times the cards don't have a verification. It's like, yeah, you can just tap everything and transactions will go through very easily. Yes, but that also means it can be stolen very easily if you don't approve if you have the auto approve on your card turned on. I don't know how to do it on mine. I have tried. Okay, I need to. Let me just test this one more time. What is going on here? Why is this bottom one not filling quite as fast? So we're sending some circles and there's some squares and triangles that are making it up here. Understandably so. Now we're filling our quota for squares and triangles down here pretty easily, and that's expected. But why is this bottom one slow? I do not understand. Alright, so maybe what I could do instead. Let's disconnect the squares here. I'm going to disconnect this square. We'll send it down here instead, and this triangle will also send down here. The square we will send this way. Maybe the way this is sorted is not working as quickly as it needs to be. Fingerprint verification, foam and leather gloves eat up the palms. Wait. What about fingerprint verification? You mean like on your phone? Oh, geez, ran out of time in that one. Okay, so maybe I need to disconnect the triangles and we can send the triangles over here instead. Maybe that'll work. There's so many crisscrossing wires, I don't know how this thing sorts. I've never seen a fingerprint for the credit card machines. I've never seen one of those before. Learned something new today. Well, as far as I can tell, this works. It's just not going fast enough for whatever reason. Whatever. We'll just say clear for now. I'll clear this with a gold medal another time. But that one wasn't as interesting as I thought it would be. Tatari though, and Gamazon, we have some startups here that we can do for extra cash, and I think we do need some extra cash for parts right now. So let's check out Tatari. Cool hackers. Tatari, good day. We are inviting you to join our hacker startup. That's very bold. I don't know anyone that would actually introduce themselves this way. We write sheets and guides for different games. Okay, now that's different. That's different. This is different. But now we would like to try making something real cool. We need a program that will play and win in Arkanoid instead of the player. Okay, so we're making a super hard extra AI level for the game. We know that you know a lot about machine learning, so we're inviting you to participate in our startup. This is funny though. Hands barely have any fingerprint at all. Foam in the... Oh wait, I read this already. The guy had to stop using gloves for a while. Hands were getting red. Yeah. All right. Yeah, I've used gloves quite a bit also, and I don't know if they actually eat up your fingerprints though. At least the ones I had. Okay, so we just want... Okay, so this is fairly simple. This looks fairly simple. We can probably do this quickly. Now, we probably don't need a load balancer here specifically, just because this is a fairly simple thing. But if we wanted to make it more efficient, I guess we could. For future things, we could probably do a load balancer here to sort it out really quickly, and then splits 50-50 top and bottom. And so we will do a if else here after that. So if it's red, it goes up here. If it's blue, it goes down here. And then anything, all the green should go in the trash cans. Now so this is pretty much free form for the startups. DoD program. DoD program initiative looking for external sources probably. Yeah, it's possible. It's possible. Nothing is out of the realm of possibility here. But anyway, now I get it. We only have very few a very small sample size over here, but eventually this is gonna increase as time passes. So I'm anticipating that ahead of time and putting a load balancer over here. And we have a expert system to sort out our shapes, red and blue, and toss out any greens. So let's give this a test. Can we code Doom in this game? I haven't seen any Doom things. Oh, this is way too slow. That is way too slow. Maybe... Okay, maybe not. Maybe don't need a balancer per se. I haven't seen anything about Doom recently, so I don't know. I don't know. Speaking of Doom, I haven't actually played any Doom before. But it does, because I mean, motion sickness, I get some motion sickness from 3D apparently these days. Not really great. But I do find it funny that we have a new Doom patch. I think it's like Ancient Gods or something for 2016, maybe. All right, let's try this instead. So the decision tree sorter is a little bit faster at least than our expert system over here, which is like 0.9 seconds. Decision tree is 0.27. Now, we don't really need a load balancer quite yet, because I don't know how much stuff we're going to get through here. Though I do imagine this is going to need some load balancing in the future. But it's a startup. We don't care about that. Anyway, we're sorting red and blue. Green will be randomly sorted top and bottom. So if it's red, that goes into our output stream up top, and then if it's blue, that goes in the output stream in the bottom. Now we are going to get some random greens once in a while, so we have to toss that out into the trash can. Hopefully this is not too slow, and we can do this in a reasonable amount of time. I mean, it's 100% accuracy. It has to be 100% accurate. It's just going to be a little slow because we don't have a load balancer. I don't know if it was a pregnancy test stick. I have heard something similar though. Let me check. Let's check this out. Doom pregnancy. Oh. Let me see. Doom on a pregnancy test. It was a pregnancy test. Okay. Is it fake though? Because there was. Nope, it's real. It's real. Yep, you are absolutely right. There was a programmer that got Doom on a pregnancy test. What is the mechanics behind it though? I mean, it's a very pixelated Doom shooter from what I could tell. But it looks like basic input output and CPU original IBM. No, I didn't get the results I was expecting. No. Anyway, this seems to work, albeit a little slow, so we'll go ahead and release this. And let's see how well this works. So here is our hype meter for our startup, as always. Seems like the users like it. Your scheme is failing to process all the incoming results. Try parallelizing calculations. Okay, so let's try to patch it up then. It seems like we need to actually start using a load balancer because this is not going fast enough. All right. So just like the real world, we have a cat hub over here. So this is version 1. So we're gonna do version 2 on this side. We're going to need a load balancer in the middle, and then another load balancer top and bottom. No cost is too great for this as we try to sort out this problem. So top and bottom, one bouncer goes up here, one bouncer goes over here, another bouncer over here, and another bouncer over here. Red will always go over here, red will always go over here. If we get a... It has to be 100% accurate though. It has to be 100% accurate. So what are we going to do with greens? Oh, how do we sort greens? We could use the expert system, but that just adds more time that I don't think I would like to do. There's gotta be a more efficient way to do this. It's gotta be a more efficient way, but let's do it anyway. Just for accuracy's sake. All right, so up here. So let's do 4 decision trees for speed. Now we're gonna get a mixture of red, blue, and green over here. So if it is red, it goes through here. No, we need an expert system. We must use an expert system. I don't feel comfortable doing this without an expert system. I don't know anything about. I don't know anything about Seaman. Did he get lost in the south somehow? I'm hoping that's actually an actual joke that that I was missing. Okay. So if else red will go over here. And then maybe we can use an expert system for this. We're going to connect these systems down over here. Oh, we don't want that though. Oh, this is going to be a mess. It is already going to be a mess. Does the SR symbol in Blackbird confuse? Wait, let me make sure if I read that correctly. Does the SR symbol in Blackbird confuse today's engineer and programmers' terms of designing? I don't know anything about the SR symbol in Blackbird. So I can't comment on that one. I can't comment on that one. Seamen, endless orifice of the ocean. I knew, okay, Doobie, I knew where you were going with that. It's just that it seemed a bit of a stretch with a punchline. I feel like the punchline was a little bit stretched out. The punchline was a little bit stretched out, I feel. Okay, so if it's blue, we go down here. If it's green, it's going to go in the trash. If it's red, we're going to go up here. If it's green, it's also going to go in the trash. All right. Maybe this will work. Well, it works accurately. A little slow. We're getting some clogging over here, as expected. But let's see if this patch. Let's see if this patch is good enough. Okay. We're getting quite a bit of dissatisfied users. Probably because our speed is not very good. Yeah, I know I really shouldn't be doing these side quests, but we need extra cash for parts. And okay, let's patch this up really quick because this is not going according to plan, and there's a lot of dissatisfied users. So okay, so from what I understood yesterday, you want your fast processes to be up front. That way, the sorting will be quick. However, this expert system is getting clogged up really quickly. Yep, use it to learn more about your cat. The thing, okay, so here's the thing. So here's our progress on our cat learning. Can you see my mouse on the screen? I can't see my mouse on this. I can't see my mouse on OBS. I guess it doesn't work too well. But anyway, if you look up here on the top right, it says cat speech recognition system, 59%. We were trying to find detect the emotions on our cat. And we did. We actually did that to a certain degree up on this point. But now we have to improve recognition of cat emotions. So, yeah. Second zones using easy HTML, mild Java, yeah. I mean, you don't really need too much these days for that. Turn to took you 5 days to learn how to use a coffee machine. Well, if it's a fancy coffee machine, I can understand that. Okay, You know, I'm just gonna let the startup go into the ground. We're getting more and more dissatisfied users, but I don't care. We're still getting some income. we're getting some good cash. And our income is just now negative, so we're gonna sell our startup. Got some decent cash out of it. 3 buttons is nothing on a coffee machine. How hard could that be? Okay, that's enough of the side jobs. Let's go and actually do the main quest. Genetic algorithm, complex emotion recognition, part 2. Okay, I'm out of ideas. Half a time, the cat's emotions are recognized as proud and classy. It's the time my cat is usually licking unspeakable parts of its body. Oh boy. I guess it feels real classy while doing so, but what if I'm wrong? Dog Kings. Try the genetic algorithm genes rule. Or was it Jin? Or maybe a genie. Gotta check it out. Genetic algorithm genes rule. Watson versus Crick. Genetic algorithm is the answer, but you need multiple cats to properly train it. Dr. Coder. Jeez, you guys are so stuck in the 80s. Ruka at Cat Meow, come back when you sick of waiting for millions of years while natural selection works as magic. Worked with carbon-based life forms, didn't it? What are you talking about, Dr. Coder? I don't understand what you're saying. Genetic solver, okay. Train model and train run till the evolve button lights up, then click on it. It creates a clone with modified error, positive or negative. In the real world, one of the most powerful self-learning non-neural algorithms. It simulates biological evolution process, proliferation, mutation, extinction. Only solutions which close to the optimum can survive. I don't know about that. We have a question mark for an error rate. I don't know how I feel about this. Looks like we can only use 1 for our sorter. Alright, well this is the tutorial stage, so red goes to red, green goes to green, blue goes to blue. And then let's train it until it... Okay, and then we got evolve. Stop. Evolve, okay. Do we toss this out? Evolve. 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 I don't know what's going on here. Evolve. 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 Huh? Okay, let's back up a bit. This is getting a little bit too messy. So this is our copy of our evolution. So we're going to go ahead and destroy this one. When something looks simple, but when you take the time to look into it, at that point your brain cells goes, we have an emergency, we're having a meltdown. Yeah, I destroyed that evolution because I have no idea what was going on. So let's sort this out again. Okay, I get it. So the error rate keeps going down and down. So this is our parent and this is our offspring. The parent is now obsolete. Sorry, parents. And now we're going to train the offspring and evolve it. Now here's the thing though. Gameplay wise, I don't know if there's any reason to do it like this. 28% error rate. Well, that's good. Okay, stop it. And then we're going to evolve again. The nodes on the field have reached their minimum margin of error. There's nothing more you can teach it. But can we go below 9%? Alright, American Bison, thanks for dropping by. 9% is the error rate for the genetic solver. But the thing is, did we need to actually go through the evolution process to do that? Can it just not self-evolve? Apparently, it's trying to teach us that evolution step for whatever reason. But at least now, so the sorting is a lot better. Yes, I know. You can always make it smaller, but apparently... So the way I understand this game works is that it's actually taking you through the steps of machine learning. So we're only using the tools that were available at the time of certain periods in machine learning. So if you look to the left here, we have first steps 1966 to 1998. So we only had a limited set of tools for this period in machine learning. And the Mark I perceptron was very inaccurate in today's standards. 20% error rate, apparently, according to the game. So while yes, we could try to get to 5% or less, that just wasn't feasible at the time. So we keep going through here, and then now it's 1998 to 2006. The genetic algorithm is a little bit better than the Mark perceptron. And I think this is a chess bot that's going to beat the world champion at the time. I have heard this story. Gasparov at bear.roar. Oh, we're not no more cats, it's bears now. Let's see what we got here. Chessbot for training Gasparov. Hi, as you may know, Gasparov is to compete with AI chess computer next month. Can you write a chess bot for training? Yeah, sure, we can try that. We can try to write a chess bot. But before that, I want to see if there's any parts available. What do we have new? These are decorations. I'm gonna not do decorations for now. This is new nodes, only one node left to unlock. What do we have here? Data transfer speed by 6%, increased node work speed by 6%, increased node speed by 2%, and data transfer by 2%. I don't know anything about bear driving simulator. I didn't even know that existed. Let's get the GVidia 1080 Ki. Seems to be a pretty good graphics card. And hopefully that'll make our processing a little bit quicker. Alright, let's see what they got for us. Oh man. I remember excuse me. I remember when this was a thing. World champion versus genetic algorithm. So that was an experiment with a genetic algorithm AI? Really? It's almost 40% faster, yeah. One of the greatest chess games of all time, without a doubt, was the battle between Garry Kasparov. Ah. So Kasparov was... I don't remember what the guy's name was, so it was Kasparov. Kasparov and the Deep Blue supercomputer by IBM, I-1997. The first game was very difficult and tense. Kasparov had an advantage at first, but starting from move 44, many believe that he ceased to understand the logic of the computer, and in the end lost the entire game. Man, I heard about this news back then. It's just kind of amazing. I think people were taking bets on who was going to win, the computer or the guy. And no one ever thought the computer would win. You can use custom nodes to make a task easier. Yeah, we're not going to use custom nodes. Well, in this case... Well, maybe in this case we will, because... Pre-trained genetic. I do want to copy this genetic solver. Can I? No. Well, we already have a pre-trained genetic solver, so That should make it a little bit easier. Actually, that's not. We're gonna retrain it. Can we retrain it, or can I just copy? Can I just copy this and paste it here? No, it won't let me paste it here. So what's the point of using a pre-trained node then? So red, green, blue. Okay. Use the pre-trained thing. Red will go up here always. Green will go up here always. Blue will go down here. It seems like we need more reds than green. Well, we need more reds down here. Well, since this is pre-trained already, we don't have to train it again. That seemed to work quite well then. If we had to retrain the entire thing, that would take forever. So I guess this is the better way to do it. All right, well, the guy is screwed in his chess tournament. Have you seen our shop yet? Why earn money if you're not spending money? Go to, okay, this is a real cash shop here, full of goods and stuff. All right, so it looks like we need to complete both of these trees to keep progressing upwards. So let's try this RL1. Reinforcement learning, number 1. Not a cat again. Hello, use make good car. By why humans drive car to tune it. Please make computers learn itself. We don't have many human drivers, but we has many cars. Yours, Dr. Meow W. Cats, human person. Very specific denial there. Very specific denial. All right. So we have our SIFT training tool again. But this time, hopefully this time it's going to be a little bit more accurate. So all we have to do is feed both road and caution signs here, and then we're going to tune it. Genetic algorithm is a subcategory of supervised learning method. Works pretty much like natural selection does in real life. Yeah, it kind of does, to be honest. It kind of does. Especially if... let me see if I can find that video that I was talking about yesterday with the machine learning car thing. Machine learning car simulator. Machine learning car simulator. Deep learning cars. Yep. I'm gonna put the link in the chat. Went to grab a shake and left my laptop on with Abuela. Saw a screen with you and asked if you are Naruto. Yes. Yes, Abuela. Soy Naruto. Okay, so anyway. So I'm posting a link to the deep learning car. What is it? Deep learning cars. So if you want to check this out, this is the thing I was talking about yesterday, where you have to train the AI so many times, and where you have to train the AI so many times, and eventually after like 200 generations or so, you get a car that does not crash. Or at least there's a very, very low probability of crashing. Which is kind of what the genetic evolution algorithm thing here is also. So check that out when you get a chance. It's interesting. I feel like it's interesting. Just seeing the many crash cars before you actually get one car that doesn't crash, and the work that involves to get a self-driving car. Species crossbreed, multiply, mutate. In theory, after many iterations, this could give birth to the perfect specimen, or so we hope. There is no such thing, I would think, because you have to keep adapting. The goal in this type of task is to make the AI clever enough to be able to reach the target average speed. Each iteration of learning, an epoch, contains several solutions, regulated by population size parameter. At the end of the epoch, only the best solution gets to survive and multiply. Selection percentile parameter, which is kind of the same thing that's happening in the link I posted below. Genetic algorithm is not too stable, pretty much like natural selection. So if you feel that your car is not making much progress, you can try generating a new population. Just make sure not to overuse this feature. Alright, percentage of selection. Let's try 10%. Population size can't go too high. Let's do 100. And let's train it. Let's do an auto evolve. It's going to be very expensive, but it's hopefully more accurate this way. So that's the training is done. It seems to work fairly well. Now let's do a test run. Well, it sees the car, and sometimes it's a little bit too late. Average speed is 57.5 miles per hour. AI cost is 3,000 cat bucks, but you know what? It's good enough for me. Accepted. There we go. Let's do a switch over to prediction of winnings. No, let's keep doing the reinforcement learning. Let's keep doing this one. Hello, thanks for making a car. Can you please improve the car now? Is making mistakes when too many cars on road. Yep, you have congested lanes and it's gotta deal with that also. At least this part's easy. We're just gonna connect everything. Nothing too complicated here. Mutations. At the end of an epoch, solutions can mutate. The probability of this is regulated by species mutation probability parameters. So if we want more mutations, then we increase this probability. When a solution mutates, several genes from its chromosomes are selected and altered. This process is regulated by gene mutation probability parameter. Didn't you say this already? Gene mutation probability, species mutation probability. Now, I don't know if I actually want to do that. Percentage of selection is 10%. We'll keep it there. Population size, we're going to max out because more samples is always better. Now, the mutation rate. This is the part I'm not quite sure. Maybe a 5% mutation rate. You generally want your mutation rates to be, unless, well, if you want to make the AI evolve quicker. What would be better then? 50% species mutation probability is quite high. Let's make it 10%. On the conservative side, gene mutation probability. Maybe we can make that. If you go like 50% mutation probability, that you're talking about mutation speeds on the scale of like the flu virus. The flu virus mutates every freaking year, and also this this COVID strain also does the same thing, from maybe a little bit of slower rate than the flu virus, from what I understand it. God's game disguised as a programming game. Now, here's the funny thing. Machine AI, machine learning is essentially that, especially if you're trying to teach it. It's kind of the same thing, right? But let's be conservative here for the most part, because as far as mutations go, species mutation, I don't know how this is going to affect the outcome of our AI population. So let's keep this both at 10% and see where it takes us. Yes. Yes, it does. So you know how for the flu we're generally advised to keep getting a vaccine every single year because of how we keep. Okay, let me start over. So with the flu virus, you're generally advised to get a flu vaccine every year because the flu virus itself mutates very, very quickly. The reason why it mutates very, very quickly is because it's an RNA virus. And RNA and DNA, so if you're not familiar with RNA and DNA, let's just make this really simple. DNA is 2 strands. Those 2 strands connect to each other, and each strand has to be complement to each other. So simply speaking, let's say you have a ladder. Let's imagine that ladder is your DNA, and one side of the ladder has to match the other side of the ladder. Otherwise, you cannot. That ladder will not be stable. So both sides of the ladder have to link up to each other, and because they do link up to each other perfectly well, it is a stable ladder, and you can use it. Now for RNA, let's imagine that ladder was split in half. Now that's not a very stable ladder, is it? It's my analogy might be bad in this case, but imagine a ladder was cut in half. It's not very stable. In the same way, your RNA strand, which is only a single strand of genetic code, things can shift in and out of that RNA strand very, very easily, and because of that, the mutations are really, really quick. I'm using a very bad analogy for something very, very complicated, but that's what's coming up to my mind on the fly. Wait, let's do a test run. I'm not sure what happened here. I don't know if this species generation and gene mutation probability is any good. Looks like our speed, though, is fairly decent. We did keep an average speed of 56. I'm going to err on the side of caution whenever these mutation probabilities come up, unless we need to go like super, super fast, and then maybe we can increase the mutation probability, because we need it to go faster and faster. But I think that cleared it just fine. Let's see, how much cash do we have? Can we buy any new hardware? I don't really want server cost stuff. Data transfer speed increases sockets processing queue. I don't think that really does much of anything. Let's do transfer speed over here, and then let's get socket queue, increase our RAM a bit, and then for everything else, I don't really care about server cost decreasing. Let's maybe upgrade our CPU. That would be the last thing I can pop. Nope, let's save up. Never know what expenses will come up. Better have a balance than no balance to work with. Oh. Okay, so, well, before we do the UFO, let's try doing the prediction of winnings before we do the UFO. By Ben Mesrich? How do you pronounce this name? Hey there, you know, I'm a big gambler. I'm going to Vegas next week and hopefully I'll make some money. Did I say some? I meant to say huge money. I need you to write some code or whatever you do there and predict all the ways to win in roulette. Roulette? If you do everything right, 5% of my score is yours. Please find some related data enclosed. Okay, roulette is not exactly something you can predict winnings from. I mean, roulette is very RNG unless you know where the thing is going to stop. Alright, so let's do a genetic divide. Not this one. Pre-trained genetic. Because I don't want to have to train that thing over again. And we're definitely going to need the bouncer. Send one up top, send one up the bottom. Now top is red, so we're going to need red to go here, and I need another red to go over here. And then everything that's not red can go into the trash. Alright, let's give this a test run. And it is all right. Probably not the most optimal solution. I just didn't want to have to retrain the darn thing. I wonder, was there a better way to do that? I don't really think so. I really don't think there was a better way to do this. We'll take silver. I'm not going for all gold right now. We'll take silver. I just didn't want to have to retrain the AI. Did we learn anything there? Nope. Not at all. Not at all. Dennis Daly. UFO recognition system. Hey, please help me. Aliens want to kidnap me. I'm building a large station to keep an eye on the sky around my house. But the image recognition system does not work. I know that all the Martian ships have round shapes and those from Venus are triangular. Please divide them into 2 classes. I must be... Oh boy. I think Dennis already got abducted before the email was sent. Oh boy, poor Dennis. Poor Dennis. Oh well, we still have got a job and we got the money, so we might as well finish it, right? Decision tree shape. This node compares socket's shape with element's shape. Okay, so this works like the colored sorter. If the shape is equal to one of the sockets, then it moves to that socket. Otherwise, it's going to move to a random socket. Real world, decision tree more complex. Dependencies, each question, okay, no. For example, each question may be a SIF node, which is trying to find eye, mouth, tail, or wheel. As a result, the decision tree may detect a human, a mouse, or a car on an image. Which we're not doing that here. Okay. Well, it looks like there's only circles and triangles here, so... Oh, this is a tutorial, that's why. That's why it's easy. But it is a little on the slow side because it's less, it's 0.855 seconds. Oh, well, that was tutorial. You're meant to clear that really quickly. Oh, what do we have in C-Bay? Oh, new stuff arrived. We got mood! We got a mood poster! You know what? Let's get the mood poster. It's cheap. It's cheap enough. There we go. We're gonna get a mood poster, and cat skins, still no cat skins because these are expensive. The moralist, apex of the evolution. I don't know this reference. What is this reference? I do not understand. Curious outfit? No. Alright. Let's see. We got the mood poster that's being covered up in the back. Alright, so let's continue on. Let's continue on. Photo parsing. There's a lot of basic machine learning nodes here, and not too much of the neural networks, which is what I think the one I enjoy the most. It seems like most of the neural network stuff has been relegated down here to the bottom. And now we're back to basic machine learning of photo parsing. Uka Sarasti at Katmiao. Photo parsing instrument for a construction company. Good morning, we work for a construction company. We need to ensure that the windows we want to install are designed accurately. Fair enough. Please create a program for smartphones that could proof check our designs for potential mistakes. I guess if you're out in the field all the time, smartphones would be a lot easier to carry around than a laptop or some sort of PC. Oh wow, we only want squares. We only want green squares. All 10 green squares. And we can only do it in 2. Okay. Alright, so if it is square, you get sent directly into here. And that is within the margin of error. And if you are a triangle, excuse me, we are wanting to trash you because we don't want you. There's a lot of triangles here. Not as many circles, so hopefully some of those circles get randomly tossed into the trash can and they don't make it to this side. But if they do, it's not a huge issue, I would hope. So let's check this out. We're not getting many squares. It seems like it's a very slow sorter. But it does the job. 70% accuracy over 60 that we were shooting for. Go ahead and clear that. Very simple. It is basic machine learning, so it's not very difficult. Random Town Council. Oh wait, we got something on private email. What's going on here? Mail from Lottery Committee. What's going on? Gold Lotto at Katmiao. Hello, you've registered in the prize-winning lottery prize pool. We're happy to let you know that your registration number won in our last drawing. Congratulations, the money will be sent to the bank account stated during registration. A lottery that actually works? Okay. This is not what I expected. Usually when you do a lottery, you don't win anything because that's how lotteries work. You keep increasing the prize pool if it's actually legit, but guess we want something. There must be something wrong with this lottery. Not that we're complaining. We just upgraded our graphics card. Now we're gonna upgrade again. Alright, fine. We'll upgrade that. We'll get a new processor also. Decrease server cost by 10%. Sure, why not? Let's decrease the server cost. I don't think that's an issue. And then let's save some cash just in case. Proceed. Hello, we are optimized roadway traffic. Hello, we are repairing the road surface in our city every day. Not surprisingly, it generates some problems with the road traffic. We ask you to write a pathfinding system. Thank you. Pathfinding. So pathfinding. If you ever used like Google Maps or Waze, the pathfinding on those are generally assisted by the GPS, right? But there is also some machine learning involved. As the GPS, as the program uses the GPS, as well as current road conditions, if it's something that it does use, like traffics, user-reported accidents, and road blockages that the GPS may not know. Ooh, need some water. Let's see. There, yeah, it's pretty complicated stuff because you got to find the shortest path and all that stuff. And there's so many roads and so many ways you can get to from point A to point B. GPS cannot tell you anything except for roads that are currently existing, hopefully. Sometimes the GPS sends you to places that do not exist whatsoever. Ooh, excuse me. Math data representation, main axis of the fish. What? In many cases, data is represented by obvious parameters: gender, age, salary, distance, or the distance to the nearest fridge in meters. This kind of data is suitable for any human being. Perhaps you're already familiar with the concept of correlation, which is also a fairly good parameter for analysis. Some people skilled in using simple mathematical dependencies are called analysts. Truly hardcore mathematics go even deeper and describe data with distributions or even, oh boy, conditional probability distributions. Conditional probability, oh my gosh, that's a huge mess by itself. Those principles cannot be explained without a whiteboard and a math degree. This is where machine learning steps in, and sometimes algorithms are capable of finding dependencies that couldn't be even imagined by the brightest human mathematicians, because it takes way too long otherwise. Computer is much faster, but we gotta tell a computer how to do things. Okay, so 31 seconds, we sort things out. Okay, so let's get our load balancer in here. And then, what is our fastest node? Decision tree. Aha. Now let's use our sift. Let's use our sifter on one end. It's not much faster than the this decision tree shape, so let's just use sifters for now. So let's put a load over here, put a load over here. If circle, fairly simple, let's put it up here. Otherwise, we send it down to this bottom sift. If it is... oh no. Well, hold on. Let's get rid of that. Maybe we can use a random forest instead. A random forest might be better. Maybe we can use 2 random forests. This will be easier to sort things out. So let's connect these random forests. If we get a circle, send it up here. If we get a square, send it over here. Otherwise, triangles go down here. And it has to be 100% accurate somehow. And then we'll just copy this because it has to do the same thing. Now let's give this a test run and see how that works. Accuracy seems good. Sorting, on the other hand, a bit on the slow side as expected. But I think that was the easiest way to do it. If we didn't have this random forest generator, if we didn't have this random forest tree, what would that solution look like? Watchdog symbol? What is a watchdog symbol? I've never seen the watchdog symbol before. Watchdog symbol. Oh! What is this? I have never seen this before. It looks neat. Like I do see what you're talking about. What is the watchdogs? I've never heard of that. I've never heard of it before. This is new to me. So I guess if we didn't have this random forest node, which makes our job a lot easier, it does give us a 7-node limit. So with a 7-node limit, what we could probably have done is use a sifter on both ends. Hacking game, open world GTA hacking game. Oh, that's interesting. That's interesting. What we could have probably done here, since the load balancer distributes a load evenly, so supposedly, what we could have probably done is use a decision tree sifter. On both ends. So if it was so since it's gonna get split up evenly, we could have done circle over here, circle up here. No, we're gonna need one more. We're gonna need one more. Another decision tree shifter. So circle would go over here, and circle would continue up. Now triangle, if we get any triangles, triangle would go down here. Same thing for this bottom one. It would do the same thing. Now we have a random square that might infiltrate this. No, well, let's disconnect that because we'll get random squares, top and bottom. So we would need one more. We would need one more. Maybe over there. Okay. This would get messy really quickly. But circle, 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 circle. And then triangle. Could probably do a triangle here. And then triangle also goes down here. Now if we get a random square from up top, that will go down here. Now triangles will always go down to the bottom. Circles will always go to the top. The squares are what you don't want. Squares would probably go down here. And triangles will go down here. Circle is already up there. Triangles, so if we do get a random square, that will get shuffled into here. And triangles will always go down here. But if you get a random square, that also will go over here. I think this is the solution if you didn't have the random forest node. This one, which makes it a lot cleaner and faster. Otherwise, it would be shuffling around like this, and it's a little bit slower, but it still works. It does cost a little bit more, apparently. So we're going to go ahead with our original solution over here. I'm glad to know the other one works just as well, though. This, on the other hand, probably not quite as fast, but I feel like it might be a little bit cheaper. No, wait. We spent 89 cat bucks. How much did this spend? That's a lot of parallel actioning going on there. 79? Really? You know, well, let's take this one because it's cheaper to make, despite how complicated this whole thing looks. It's like, holy crap. This is probably super messy to look at, but this is exactly how it's supposed to be done. If we didn't have the random forest. Random forest just makes it cleaner to look at, but this is supposedly a little bit more optimal. Alright, we'll accept that. Fast data sorting. Oh wait, what do we have in Seabay? Hawaiian room decor. I don't really want that. Chair, like a boss. That does not look very comfy. U-phone. Buy it and be cool. No, I refuse to buy a U-phone. I refuse to buy a U-phone, even though I am using a U-phone right now as a camera. I refuse to buy it. Let's go for the Samsung instead. I'd rather support Samsung. A Samsung over here. Nice and purple. See, how much more does this have? It doesn't look like we're too far off to the finish. So we'll try to finish today. We'll try to finish today. And then the side quests I'll just do on my own time. Alright, fast sorting. Scientific Center at CAT. Fast data sorting. Good morning. We have a scientific satellite that aggregates data from our geomagnetic researches, but we need to put it down and launch a new one to orbit. Can you help us extract and process the data from the old satellite? Okay, that's fairly reasonable. That's fairly reasonable. Oh wow, this is very specific. Okay. And seems like we have up to 14 nodes that we can use. In that case, we're going to need quite a few bouncers to get this processing quickly. We have a 40-second time limit. So bouncer up top, bouncer at the bottom. Now, what do we do after the bouncers? We're definitely going to have to trash some data. And this is going to be the slow part. Alright, so we're going to need the decision trees. Let's use these decision trees. So bouncer connect to the top, bouncer connect to the bottom. So we're going to get an even load of everything. So we need to actually sort by shape also. I'm trying to avoid using the random forest and isolation forest nodes because those were bought in the shop and that's not necessarily part of this exercise. So red will go up top only. Green will go here. We only need 10. We only need 10. I guess we can do any. So there's going to be some colors that are sifted downwards into the trash can. Alright, so if it's red, and it's a red circle, we'll toss it in there. Otherwise, if it's any other shape that's red, toss it into the trash can. Let's see. Now, I may have too many bouncers here now that I think about it. Let's use less bouncers. Probably just need a bouncer at the start, because we need a 50-50 split otherwise. Let's try this. I wonder if we should do shapes first or colors first. Well, let's do colors. Let's do colors. So we want all reds up here. If it's any other color, including red, that's probably going to go into the trash can. Well, maybe not the trash can right away. Let's say green. Let's say green. And then we'll go to the shapes shape sorter. So if it's red and it's a circle, we're going to send it up here. Now if it's red and any other shape, that goes into the trash can. Now if it's green and a square, that gets sent over here. Otherwise, that also goes into the trash can. Now for this bottom one, if it's blue and a triangle, that goes in here. Otherwise, that goes into the trash can. Let's make a separate trash can down here. Now, we'll probably also get some greens or red. So we can probably do any, and then we'll make another decision tree over here. If it is red, and a triangle, send it up there. If it is green and a square, no, if it's we might get, if it's anything else, let's trash it. I don't think this is going to work too well. We're probably actually going to have to use our random forest and isolation forest nodes because this is going to be too complicated otherwise. And accuracy is tanking hard already. That's not a good sign. Not a good sign. Alright, that is... Let's not make this any harder than it needs to be. Let's go ahead and use the load balancer. It seems like this is like the next, the final puzzle of this part of the story, of this part of the story, so it's intentionally difficult, it seems. Alright, let's see here. We're gonna need load balancers off the wazoo. Alright, so we're going to need some isolation forest. So for this isolation forest, if it is a red circle, send that directly up there. Otherwise, we're going to deal with it some other way. And now if this is a blue triangle, we'll send this down here. Else we'll deal with it some other way. And else is another isolation forest. So we'll send them both over here. If it is a green square, we'll send it here, else trash it. Now this is the simple way that I can think of to deal with this. If we were to use if we were just used to tools that did not have random forest or isolation forest for this pathway problem, it would get complicated very, very quickly. So let's not try to do that. Just make things a little bit easier on ourselves. Now, whether or not that is actually going to go fast enough, that is a different story. It seems like I got a bottleneck over here happening in the decision trees. And we can probably do this faster if we used smaller... Yeah, so this would work if we actually had enough time. So this is our current solution, but it is inaccurate. So let's just copy all of this stuff, and we have our third cat hub. Third cat hub area here to work with. Quick sort. I don't know my quick sort algorithms. That is something I have never learned thoroughly as far as sorting algorithms are concerned. All right, let's get a balancer over there. I think we only need one balancer. Hopefully we only need one balancer. All right, decision tree over here and decision tree over here. Maybe, let's see. If red 3, if color 3. Doesn't really matter which one I do at this point. All right, so let's connect top and bottom. If red, then we send it on its way to a shape sorter. If it's circle, it will go not yet there. It will probably have to go through another shape sorter to make sure, is it actually circle? Is it actually circle? If yes, let's go over here. Otherwise, if it's like a square or something, that goes into the trash can. Trash can over here. Now we want to send our triangles also into the trash can, as well as any stray red squares. But we might get a few stray red squares up here, so we're sending them both into the trash can this way. And then we do want to process our other colors, such as blue and green. So if we get a green, we'll deal with that. Let's do shapes down here again. So if we get a blue, we make sure it is a triangle. So that's 2 decision trees over here. And then if it truly is a blue triangle, we send it down here. Now if it is green, we'll deal with that another way. So if it's a blue and a square, let's say, if it's a blue square, we will trash that. But that doesn't rule out the circles, so we will also trash the blue circles. That takes care of the bottom. Now, we have to deal with the greens. So we're going to connect green this way. And now if it is a green square, we need to make sure it's actually a green square. And if it actually is a green square, we'll send it down to this stream. Otherwise, if it's a green triangle, we're going to send it to the trash can. If it's a green circle, that also goes into the trash can. This looks messy as heck, but I think this might work. We might time out, we will see. All right. Accuracy is not great in the middle, and nothing is going to the bottom, it seems. Why? Because I did not sort it. I did not connect it. I did not connect this. Accuracy is still a problem, though. Regardless. Let's give it a try. So we are getting random colors also. Ah. We may need a clause over here. Is it really blue? Is it really red? So let's disconnect that. Let's make sure it actually is red before we do this. And then if it's a blue, we'll send it down below. And for this one, we want a blue triangles only down here. But is it really blue? Is it really blue? And then if it's red, we'll send it elsewhere. All right, so if it's green, we send it, where should we send green? I guess I can send green this way. Now what do I do with red down here? If it's red, I can probably send it up this way. That should help. If it's green, I probably need a clause that says, is it really green? And then maybe trash it. I think there's going to be some accuracy issues with this one also. This mess is probably going to have an accuracy issue. Oh, I can zoom out. I didn't realize that. We may have to zoom out in a future problem. Let's see if it's actually green, but we might get some red. Well, let's just test it out and see what happens. Speed issues aside. Hopefully there are no accuracy. Okay, no, we got a little bit of accuracy issues in the middle. Understandably so. Understandably so. Low accuracy and ran out of time. So let's take this solution. What was the issue with this solution? Let me see what the issue was with this solution. Because there should not be any accuracy issues with this solution. There might be some speed issues, but there shouldn't be any accuracy issues. If it's a speed issue, then we can deal with that. What we'll do instead is make a parallel. We'll make a parallel processing, and that should speed things up a little bit. It's probably the most straightforward way to deal with this. A little bit of a bottleneck over here, but that's to be expected. Now, is it going to finish in time? That is the big question, and the answer is no. A little too slow. A little bit too slow. We need to sort by colors first before we do anything, it seems. That'll speed the process up a little bit. So we can't have this step be a long step. The long step has to be over here. Alright, let's sort by color first. That's probably going to be the safest bet. Alright, so we want red up here. And let's say blue down here. If it is green, then we'll sort it out in this middle step. And then we might get some random reds over here, but that's fine. Now we'll do our parallel processing. So if it's actually a red circle, we'll send it up here. Otherwise, it goes into the trash. We'll send our greens over here. If it's a green square, that goes there. Otherwise, it goes into the trash. And then if it's a blue triangle, that goes over here. Otherwise, it goes into the trash. And then we can probably use one more isolation forest node for parallel processing some more. So again, we will copy this, paste that, connect this green node over there, and then trash everything else. Hopefully this fourth version works better and faster. Faster is what we want. And that seems to work just fine. Now let's review. Let's review really quick. What did we actually do? We made decision trees over here. For color first, because this is a fast step. So I think generally what you want to do whenever you make these schematics is do your fast steps first and then route them to slower steps that can sort things out more accurately. So your slow steps are more accurate than your fast steps. So what was the issue with this mess? The issue with this mess is we have so many decision trees that just got messy and it got really, really tough to track where things were going. Now, how do I get this solution to come out the same as this one? I cannot tell you. I'm not sure how to tell you that because it is complicated. And else statements are definitely my friend in this case. Anyway, I think we'll just go with the solution. It's a lot cleaner and a lot more user-friendly. So we'll go ahead and release that. Okay, what do we get for new hardware? Work node speeds 1%, DLL slots. I never actually used the DLL, so we're not going to. We're not going to buy it. Tambourine. Why a tambourine? I understand. Why a tambourine? Alright, let's keep going. So, oh, excuse me. I actually unlocked silver for the previous set of problems, but it seems like you need to get a certain amount of gold, silver, or bronze to get cutscenes. I think that's what this is. So let's check silver. So I guess there's different endings depending on how well you do. Okay, we need more cats to collect data. You up for a party? And so now we're doing a Zoom meeting with cats. So many cats. This is a neutral face. This is an angry cat. This is a happy cat. This is a sad cat. Oh, happy cat has a kitten. Very nice, very nice. Cat emotion database. More data is always better. Can't base everything off just one data point. And now our cat emotions is more accurate. Improve cat emotion recognition. Check. Very nice, very nice. Cat speech recognition, how to. Gotta admit, Dr. Coder was probably right. This genetic algorithm is just too clumsy, especially now. when I'm starting to work with speech recognition. Watson versus Crick. Hey, come on, you haven't even waited for a year. Have some respect towards the natural selection, why don't you? Yeah, I made a lot of improvements to perceptrons since Old Man Rosenblatt was around. Now, they tend to join multiple perceptrons and big bad neural networks. Something like that could work out for you, but don't forget gradient descent. It's like a life coach for your neurons. Helps them keep on the right track. Maintain accuracy level. In certain tasks with perceptrons, you need to keep the accuracy of your data flow above the required level while the timer is filling. While the timer is filling. If the accuracy drops, the timer will be reset. The timer is only active in test run. What is this? Perceptron shape. Okay, no. So this is just the... We've used this perceptron shape before. Tan, Relu, sigmoid. Perceptrons are basic elements of each neural network. Okay. So, but this is hopefully less... more accurate. Hopefully it's more accurate. Perceptron shapes. Okay, so we had the Mark I perceptron before, which also distinguished shapes. But this perceptron shape seems to be more accurate than the Mark I perceptron. And then gradient descent. What is this? Each element in the game has a small error fix value. This node increases this value. This node doesn't work in test run. Huh? So what does it actually do? In the real world, gradient descent is one of the basic algorithms which can train models, not only neural networks. Gradient descent calculates gradient of all objects and steps closer to the target answer for the task. It takes a lot of time. Yeah, I'm not exactly sure what it's supposed to do though. I guess we'll figure it out. Well, these both take the same amount of time, so I think... Maybe we'll send it through the gradient descent first? Well, thank you, Doobie. You too were a sugar bomb. You too are a sugar bomb. I made some oatmeal cookies a few days ago, and I would share them also, but I ate them all already. I'm sorry. I am sorry. I don't know what this gradient descent thing is supposed to do, to be honest. I guess we'll just try it. We'll just try it. Honestly, I'm not sure what this is supposed to do. But the last test was a doozy, so to say. So supposedly, as far as testing goes, the error rate is supposed. So this is actually a time test instead of the collect number of data sets like we've done before. So within 10 seconds, we have to keep a 70% accuracy on all of these shapes. And at least our perceptron shape is better than the Mark I perceptron, where it's 9% now, compared to the 20% margin of error from before. I don't know what this does. I still don't know what this does. Has a small error fix value. This node increases this value. So I guess we process everything through here first before it goes to the perceptron shape, and hopefully this improves our accuracy. I don't know. But let's give it a shot and see if that actually does anything. It seems to be the case, as far as I could tell. But I don't know if it actually does. Yeah, I feel you. I look at my code that I did for like a year or two ago, and it's like I try to comment up as much as possible, but the way I go about things is so roundabout sometimes. That's terrible. It's like, I don't know what's going. I don't know why I did what I did, but I did do it anyway. Gradient descent, life coach for neural networks. I still think it decreases our error rate before we actually send it to the perceptrons. Increases Hayamu router. Okay, we will definitely buy that one. And we may actually have enough. Oh, what's this? Stock gradient descent works faster than gradient descent, but may increase error rate. Let's buy it anyway. Cat skins. All right. I think we can finally afford a cat skin, but we don't have many skins we can choose from right now because cash is limited. Which skin should we go for? We got Viking helmet, cyborg, and WTLVR. Or should we save up for one of these other skins? There's Tank Cat, Kugo glasses, Wasteland helmet. I don't know who the moralist is. Towel looks like an Assassin's Creed thing, or should we save up for Iron Cat whenever that shows up? I'm kind of partial to the VR set, but Iron Cat. Maybe we should save up for Iron Cat instead. Tough questions. Let me see what else is in hardware, because I feel like I could buy a lot of this stuff, but I don't know if that makes it better or worse for us, or we can only use, or does it stack? Does it only use? Can we only like use one of them at a time? Well, we bought it. I'm assuming it stacks. I'm assuming everything stacks. So apparently we have some weird computer contraption going on now. I think I'm going to save up for these parts though. We'll save up for those parts. Alright, let's keep going. I think we're almost done. We got like not much left according to the scroll bar. Classification of viruses. Survivors. I can't that meow. Classification of viruses by type. Mayday! A strange virus is killing people in Procyon City. We can't understand what type of virus is doing that. Please help. This message was sent to all programmers in the world. Wow, huge budget for that if you're sending it to every single person in the world. Well, let's see. Perceptron color. Okay, so there's the same thing as our shapes, except now we have colored shapes. While training, the perceptron reduces the amount of errors. Okay. Read that already. Stochastic gradient descent. Each element. Okay, we did it already. This node doubles the value. Use it wisely. This node doesn't work in. Each element in the game has a small error fix. This node doubles the value. Use it wisely. Okay. Increases error reducing speed. Approximate error calculation. So if we want to go fast, this is probably the way to go. Otherwise, gradient is more accurate. Alright, we'll probably only just use one node for this one, because that's the limit. Alright, let's train this. It seems like the error rate is crazy high. Why? Why is the error rate so crazy high? Stop it. Stop that. Let's train you again. What the heck? While in training mode, the perceptron reduces the amount of errors trying to predict the color. Okay, well, this perceptron's no good. Let's try a different one. Let's hook this up to these. Why is the error rate going? Okay, let's try gradient descent again. Now this goes over the limit, but I don't know any other way to do this. Okay. So this helps our perceptron, so we can actually get rid of it after training. But we still used 2, apparently, according to the thing. Oh no, it's better now. It's better now. So I guess that's just a training tool rather than something you use in the actual release. Okay. Okay, I guess that makes sense. Nice. Error control. Let's try error control. Lost aircraft. Control system error. Good day. We are engaged in repair and maintenance of aircrafts. We need to be able to predict all possible problems which can happen in the air. Oh boy. Can you craft an algorithm that would do it for us? Ask those guys at the aircraft manufacturing companies, though. They would know all about errors, especially with the huge debacle with the crashes that happened in the past couple of years. That self-error correcting system did not correct decently. Deep neural nets. You thought our neural nets was really bad. Look at this over here. This is quite possibly the typical kind of neural nets that happens. There are neural nets that solve the problem so-called XOR problem, an unsolvable problem for Rosenblatt's perceptron. They have one hidden layer between the input and output layers. Such networks are called non-deep. If the network has more than one hidden layer, it is called deep. Okay, so there's a bunch of decision layers in the middle that makes it deep. If it's only one, then it's not deep. The deeper the network, the more complex dependencies it is able to recognize. For example, the current image recognition networks include several thousand hidden layers. Amazing. Quite amazing. I'm kind of curious about this this thing. Approximate increase error reducing speed. Increase error reducing speed. Approximate error calculation. Maybe we'll do gradient descent. This seems to be the theme here. And we only want red squares. I guess anything else that's not red squares will go into the trash can. Alright, let's train you for that. Maybe I can train more than one. 50. 50. This says it doesn't work in test mode. So we can get rid of this. Just plug this in and let's give that a test. So all the reds are going up here. That's good. Though I think we're going to need more than one perceptron for this. Because it's not keeping It's not keeping up. All right, so we're going to make this deep, so to say. So error gradient reducing speed, and then we're going to send all of that through here. Let's train this one. So it's going to go through a double sort before it reaches our destination. All right, and toss that out. Now I could send everything over here, but I think I want to filter out as much trash as possible to keep this unclogged. Let's give that a test. It seems to be holding up fairly well. Yeah, I think the more trash we can get rid of ahead of time, the better, as far as the test is concerned. And we got 100% accuracy for that double layer sorting. Nice. 2 brains are better than 1. Project released. Oh wow, we're getting this section is very short apparently compared to the other one. What's up in C-Bay? Hardware. New hardware. Let's get the new processor. Let's get a perfect handmade tambourine. I guess we'll just buy everything else up that we can. Node speed, data transfer speed. SSDs are nice. Let's do this one and this one. Lots of upgrades to be had. Let's go and get air cooling system because I haven't done that before. No, let's save it up. Let's save it up. All right, recommendation system. Not matrix. Not matrix. Hello, we need to build a smart system that can help students learn English faster. This system needs to be able to assign an approximate curriculum to each student. Can you design something like it, please? Well, that doesn't sound sus at all. Doesn't sound sus. Deep news. Every day since 1905, neural network architecture. In neural nets, programmers use a vast range of different neurons. Inside each neuron, a math function is located. For example, Rosenblatt's neuron use a linear function, simple neural net, which can solve XOR problem. Uses ReLU function. What's a ReLU function? These functions are called activators. For different tasks, people use different types of activators. To solve more complex issues, a combination of neurons with different activators is used, simulating the human brain. Alright, looks like we're going to need a bouncer for this one. Let's go ahead and get a bouncer here, as well as gradient descents for each side of the bouncer. And this needs 60% accuracy somehow. Alright, so how am I going to do this? There's no decision trees here. We're probably going to need multiple balancers for this. Yeah, let's use multiple balancers for the training session. Actually, let's use one gradient descent at start and then a bouncer here. That way things are a little bit more streamlined. Actually, speaking of streamlined, that's too far. Alright, so let's connect this gradient descent to the bouncer. Hopefully that's going to be okay. And then from the bouncers we can do colors first and then shapes. Which one should we do first? Colors is faster. Colors is faster. Shapes. And we need 5. Okay, I guess we just need one bouncer. One bouncer is fine. So we're gonna do shape. We're gonna do colors first. So we're gonna send color up here. And then if it's a red circle, it goes up there. Otherwise, it goes into the trash. And then we have another color thing down here, and one more perceptron shape over here. So if it is green and a square, it goes up here. Otherwise, it goes into the trash. How about the triangles, though? When do I actually use the bouncer? Do I need to use a bouncer? According to this, I may have to. And I can only use 5 nodes, apparently. And this is already getting messy. This is a lot of data to sort through, so that's why we need a bouncer. That is correct. And we're gonna be getting rid of this gradient descent thing later anyway. But first things first, maybe we can use a shape perceptron, and then the color. Let's try that. The thing is, we need multiple colors, and each one has a different shape. So if it's a circle and it's red, it goes up here. Otherwise, it goes into the trash. If it is a square, then we can send it down here, and if it's a blue square, no, green square, goes over here. Otherwise, it goes into the trash. Now, what if it's a triangle? If it's a triangle, it goes down here. If it is a blue triangle, it goes here. Otherwise, it goes into the trash. Now this one would just be this node would just be mimicking this other node. Let's go ahead and train it. We're over the limit. Oh, what? Stop. We're over the limit. But this is probably the most accurate that we can get it. So this is going to take quite a while to train, it seems. And we're already at ×3 speed. And it doesn't matter which way we sort this gradient descent. It's always going to be the slow step for this training session. All right, I guess we're going to get some coffee or something while this works itself out. Got some spring rolls in the kitchen that I haven't eaten for a couple of days. It was in the fridge, but it's in the kitchen right now. Maybe I can grab that as a snack while this thing is compiling. I am using 2 nodes extra though. Alright, let's get rid of this. So no extra step there. But we are using way too many nodes for this in particular. Let's just give it a test run and see what happens. I'm pretty sure this can be improved, like a lot. Well, it completed just fine. But I wonder if there's a way to improve this even further. Because it doesn't have to be accurate according to this test. It just has to be 60% accurate for a certain duration. And what's the best way to do that? It's all equal chances. Maybe we don't use a trash can, and maybe we don't use this last perceptron. That might be the case. And we may just have things loop into each other. So we would send triangles this way. Or maybe we can send triangle up over here. And if it's blue, we'll send it down here. That might work. And so what do we do with these other ones? We probably would loop them back into the shape sorter as a sort of way to say reevaluate this. Now that looks really messy, but I can't think of any other way to do this. At least not at the moment. Low accuracy, out of time. That would make sense. So our fast steps are the colors. So maybe if we put colors up first before the shape sorters, we can get somewhere. All right. So let's sort by colors first. We want all the reds to go up here. If it's a red circle, they can go up there. I guess we'll have to remove one of these. We definitely need the load bouncer, and we're probably only going to be using this much. Okay, so next, if it is a green, we can also send it up here. And if it's a green square, hopefully it makes its way down here. Hopefully. If it's blue, we'll send it down here. If it's red, we'll send it up here. If it's green, we'll also send it over here, just to even out the load. Blue, we want to send over here. If it's a blue triangle, hopefully it'll get over here. Green square hopefully gets over here. Now what do I do with this? If it's a green or red triangle, we send it back to the bouncer. If it is a green or blue circle, we send that back to the bouncer. Alright, this is messy, but this might work. Well, this is faster. The accuracy on this side, though, is much to be desired. Yep, that didn't work out. Am I sending greens, though? I am sending green here. And this is squares. But we're also getting blue squares here. Red squares, we are not getting red squares. So if it is if we do get it, squares, we probably can do it like this. Send it back to this perceptron. And then it can sort green and red. And we should only get blue triangles this way, though this is going to clog things up really badly. Let's see what this does. Yeah, it's clogging up the system quite badly. Circles are fine. Triangles was fine until I did something funky. There's gotta be like a trash collecting step somewhere. This works. In the interest of time, I'm just going to accept this answer. And we'll just keep going from here. I'm just going to accept this answer. I'll figure out gold another time. But this works. It's a silver, but it works. Alright. We got a bronze video. I guess we need to get more medals, gold medals and silver medals to get access to part of the story. Quiet! Okay, and the cat is now collared. Why the collar? Output. Perception stage, okay. Meow, 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 meow. Meow, 51%. Output, bird, bird, bird. To-do list. Base speech recognition. Looks like it's somewhat working. Though we're not quite out of the woods yet. Skynet, is that you? What the hell am I doing now? Please help. Cat speech recognition out of ideas. Not sure if I'm on the verge of a breakthrough or completely stuck. The cat talks, but all I'm getting seems to be random sets of words. Is there a way to get at least one or two sentences out of it? Hellraiser. Oh, whoa, back. Chill out. The internet has taught you well. Now is the time for alternate trial. Try deep neural networks, ARMA, RNN. They work good with speech, emotions, and predicting things like that. Should work. We need to go deeper. Yes, we need to go deeper. As always. Who was that guy? No one. We don't know. For RNN memory. For RNN to start predicting things, connect the lower pairs of sockets from right to left. This part of the node represents RNN's memory. What is this? Holy crap, we're getting a bit more complicated here, it seems. Node sockets are divided into two types. Base nodes and memory nodes. The node tries to calculate the next element in the sequence using its previous predictions. RNN nodes can be connected to each other in a sequence in which each next node uses results from the previous node's prediction in its work. This type of neural layer can remember some information about sequences of elements, letters for example. It can reproduce the style of a text and write another one using this knowledge. Okay, so this is like the memory, seems. We'll do another gradient descent over here. Connect this, connect here, and then why is it even necessary for me to connect this this way? Beats me. All right. Holy crap. Print hello world. Oh wow, this is like random sets of things now that I do not understand how it's going to work, but okay. Since it's encouraging us to use multiple R and N layers, let's go ahead and use 2 in tandem and give that a test run. Which did not work apparently. Maybe we'll get rid of 1 and see what happens if we just use 1. Okay, it just likes to use 1. I don't know why we needed 2. Center of Virology. Center virus. Good day, I'm representing a Center of Virology. We are studying a dangerous virus that is prevalent in African countries. We managed to stop its spread for a while, but this virus is mutating at an alarming pace, and we have to start everything from scratch over and over again. We want to create an algorithm for predicting further evolution of the virus based on changes in its 2 structures. We have accumulated data, but we need your help interpreting it. And huge bucks for this one. It seems, so I'm not sure if YouTube's gonna flag me for this, but if you remember the Ebola outbreak a few years ago, or a couple years ago, I think that's what it's referencing. In that note. Let's see, node speed. Let's go and buy this. And I don't know the details about what happened back then, but it seems like Ebola outbreak in Africa, and then it was contained in Africa. I don't know anything about the mutation part though. I'm gonna have to research that later. Vanishing gradient. Vanishing gradient's a big issue in training deep neural networks, especially recurrent neural networks. While passing through a number of layers, the gradient becomes so small that it stops changing the weights of the network, and the network stops learning. Huh. There are several ways to solve this problem. One of those is using shortcuts, gates, to pull the gradient through a layer in the network. As a result of applying this method, the LSTM layer, long short-term memory, was invented. It serves as a long-term and short-term and long-term memory for neural networks. Okay. Well, I don't see anything different here in particular. So let's go ahead and train this RNN layer. Get rid of this. Now let's just try one node. I don't think this is going to do anything in particular. At least I don't think it's going to be any particular okay, well that didn't work. Let me duplicate this and maybe it'll do something. Or maybe we have to train 2 RNN layers in tandem. Maybe that's what's happening. No, it just means we have to use 2 in tandem, it seems like. So I guess this is the initial sorting and serves as a memory, and then this is the second sorting where it actually processes in the correct order, We tried to do that in the previous exercise, but for some reason it didn't work quite as well. I don't know why though. Node tries to calculate the next element. Can be connected to each other in a sequence in which each next node uses results from the previous node's prediction in its work. Which is what this is, supposedly. But for some reason we couldn't do it in the previous example. I don't know why. We got tons of cash. Rolex Company. RNN, this bad node can write a book. And if you've seen some of the random things that come up in the internet where like AI writes music, or AI draws a picture, or AI writes an article, I think that's what this is. Someone has made an AI from machine learning stuff, and this is the future. It is the future. Rolex Company. Hello, I am working for the well-known Rolex. I was thinking Rolex, not Forex. But okay, that makes sense. I'm working for the well-known Rolex exchange company. We are engaged in currency transactions. I am leading a project, the main goal of which is to accurately predict the exchange rate of a certain currency at the time of our need. The forecast should be made for a short-term period. Can you write such a program for us? ARMA. What is ARMA? This node predicts the continuation of numerical sequences. Okay, so... Okay, this is for numbers and the other one is for letters. Additionally, ARMA highlights the output elements with colors if the quality of prediction is high. Okay, so let's look at the example here. Numbers go in, they're white. And numbers go out. If colored, then it is... it has a higher prediction value. Got it. Multiple ARMA nodes are required to achieve this quality sometimes. In the real world, ARMA is a special machine learning model designated to work with time-dependent numerical data. It can predict future indicators basing on a set of previous values. It is often used in economics, for example, to predict exchange rates. Really? I don't think I've seen that before, or at least heard about it. Alright, let's use a gradient descent. And we got our ARMA here to train. I don't know why it's necessary for us to manually connect this when they could have done it themselves. I guess they needed to give us something to do. Okay, so we have our decision trees. So if it is... I wonder if we'll get greens. We'll probably get some greens too, but... Anyway, if it's red, it goes up here. If it's green, it goes down here. And let's start training. Alright, let's get rid of this gradient descent. Oh, why is this? Let me retrain just in case. Unless there's no need to. There's probably no need to. Alright, let's do 2 ARMA nodes in tandem for accuracy. And then the decision tree will take care of the rest, hopefully. Red's going up, green is going down. I don't see any blues. That's a good sign. But we are not... getting much else. Why? Okay, let's try 1 ARMA node. Something is getting eaten up in the system. I don't know what it is. Alright, let's try this again. Red, 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 green, 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 red, red, good, green, green, red, red, green. I guess we just needed 1 ARMA node. Alright, well, release that then. Kind of funky sometimes how this game wants you to do things. It's not a perfect analogy to machine learning, but it does the job. It does the job. I can't complain about that. We got tons of cash. No more nodes to buy. We bought all the hardware possible. And so we can buy things that really have no other value. So let's get the President armchair, Agitech Angry Tomato, a new shirt, plaid shirt, be a hipster. Be a hipster. Let's see, kindergarten decor, Hawaiian decor. Let's get the kindergarten decor. Scientific assistant. We still don't have enough for the cat marine band hammer, but that's fine. Let's see, maybe we can actually get a cat skin now. 70,000 for Iron Cat? Well, everything else is extra at this point, so I want to get the VR one. And so we got VR. VR cat. Bum, ba, bum. And looks like we got takeout over here. Sad days, but it do be like that sometimes. It do be like that almost all the time. Alright, let me see what we have for equipment. Because I want to show all the new stuff. Yeah, we got all the fancy new gadgets over here. Alright, we are almost there. We are almost there. Video game reviews. Top Gamer at cat.meow. Video game reviews suck. Hey there, I'm a very dedicated gamer, but the gaming press confuses me. My two favorite game journalists are both using 10-point score system, and that's frustrating. How am I supposed to know in which way 7.5 is better than 7.4? Also, I believe some ratings might be compromised. Can you write a neural network which could predict future ratings for upcoming games? Why? I mean, that game ratings are subjective. There's no. It could be rated at 1, and it might be utter crap. Yes, but come on, it's like, why would you want to predict it? There's no reason. Also, it would make sense to omit the 10-point system. Just tell me whether a game is awesome, okay, or lame. Can you do that? Thank you. Yes, I agree. I agree. Okay, input stream 7166. Okay, let's get a gradient descent over here going on, as well as armas on both sides. Let's connect this and this and this and this. Then the manual connection of these nodes for whatever reason. All right, now the decision. Red and blue. So if it is red, we want to go up here. But if it is blue, we want to go down there. Now here's the thing, I don't know where green's gonna come up. Green seems to be the odd one out. Or maybe red is the odd one out. Okay, so I guess we want blue up here. Green down here. And the thing is, I don't know what's gonna happen as far as colors go. Well, let's train this and find out. See if there's any greens that show up. A few greens showing here. There's a few greens showing over there. And then let's go ahead and connect this directly. And do a test run. As far as accuracy is concerned, it seems to be doing okay for the most part. Time-wise, though, does not seem to be processing very well. So we're going to need another decision tree color here. We're going to send any blues and make sure if it's actually blue, send it this way. Otherwise, if it's actually green, send it this way. That might work out better. Bum. Seems to be working a little bit better. Time-wise, can we clear it? Cleared with silver. Why? Accuracy is fine. I think we used a little bit too much. So we need red. So I guess we need to fill up red quickly. Is that the case? Let me see. Let me look at this again. So we have 2 lines going into green, but I think we also need 2 lines going to red. I think that's what the issue was. Yeah, I think that might be what the issue is. So Arma is doing its job. As far as our decision tree is concerned, I need 2 lines going to red. And 1 line going to blue. But I can only connect so much. So I guess we'll connect red over here to go up here. And maybe this will actually get gold. We do have a higher error rate for red, so I think that's okay. Not as much a higher error rate for green, though. That we're not getting as much green, it seems. Yeah, I don't know how they want us to do this in particular. We'll just go ahead and use our previous configuration, which is this, and turn that in. I'll work on gold another time. Gold can be done another time. Alright, we'll release this. And we got silver. Almost there. Meow. Okay, RNN output. Finally, I can speak. Please do not buy that chicken pate again, okay? I will seriously pee in your slippers if you do. The taste of the pate gives me nausea. Sometimes you don't want to know what your cat says. Fact, you do not want to know what your pets say sometimes, apparently. Improved speech recognition, yes. And as far as the ending that we got, so there's probably a gold ending also, which I will do at my own time. Since the dawn of times, our kind was honored and respected by humans. But dark ages came and people forgot their true allies. And we got the got the Game of Thrones reference over there. Now we're together again, but do not understand each other. We've been trying to establish contact. We use sounds, pantomimes. We've been even recording tutorial videos. Tutorial videos? You mean the cat videos? Okay, those are tutorial videos apparently. And after centuries of efforts, we can work side by side yet again. We've managed to make life on Earth better for cats and humans. We were honored. We were glorified. Noble preset. So the cat's a Nobel laureate now. Also a scientist somehow. Perfect food is chicken plus shrimp puree for cats. Okay, you can have that. I don't think I want that in particular. Maybe a chicken and shrimp patty might be okay, but not a puree. No, you can have that. We've achieved it all. And cat pyramids, the Sphinx. But we're always something to dream of. But there's always something to dream of. Always. Shoot for the stars, cats. Shoot for the stars. Congratulations for finishing the game. Let's keep in touch. We might be adding new levels and other stuff to the game. Well, that's interesting. Magna cum laude. Alright, so that's the game. I need to go back to... Alright, well, so that's the game. If you actually just go through the main quests, through the main storyline, it seems fairly simple. I think you do need to get like gold medals to get the actual ending, but at the end of the day, I feel like the game is fairly simple. It just basically teaches you machine learning concepts without really trying to bog you down. The only time you will get bogged down, I feel like, is if you go to the side quests, which we mostly avoided just to get through the storyline. And the storyline is fun. It's quirky, and it's about a cat. We're trying to understand our cat, right? But yeah, it's fairly short. It's fairly short if you just go through the storyline. But if you're going to go through the side quest, that's going to take a little bit more brain power. And I would like to explore that another time. Maybe not right now. Hopefully some other time. But in the meantime, that's something a little bit different. I was hoping to finish this next week. However, our mishap with the capture card audio didn't seem to be working too well. We'll try again. We'll try to do Atelier Meru again tomorrow. I'm not sure what time I want to do it. We can try. We'll try again for around the same time tomorrow. Hopefully, it'll cooperate. So I need to remake that for tomorrow, and we shall be good. Oh, that is a lot of donos. That's a lot of donors to the Kickstarter game. I'm assuming they use Kickstarter. Not quite as much as Blasphemous, which had a ridiculous amount of people, by the way. But this is still pretty good. That's a lot of names. Shoot for the stars. We will go. I'm gonna try to gold this on my own time. Which is probably gonna be right after this stream. So anyway, thank you guys for watching. I hope you guys enjoyed this little adventure. It's definitely a little bit different from the typical stuff I do around here regarding RPGs and such. But I do want to try to do some more of these puzzle types and maybe science type games. So if you have any recommendations, please comment down below on the video. And if you would like to see more of these, please let me know. Subscribe if you haven't subscribed, and if you haven't followed me on Twitter, please follow me on Twitter. That's where I post the schedule. Also, I also post a schedule in the channel, but sometimes that gets overlooked. So it's easier to find it on Twitter if that's something you use. Anyway, I'm gonna end the stream here. Where is my tablet? Okay, where did that thing go? All right. Okay, so hopefully I'll see you guys again tomorrow for Atelier Meru, same time that we were supposed to start. Hopefully no issues again, same as today. And yeah, I think that's it. See you guys later. Have a good rest of your day. I am going to get some lunch. Goodbye.